then that it might be going to be reduce that the poverty in a particular area. So if see that the total geospatial technology, so geospatial technology, if I'm saying what are that the important four, already I spoke on this, that GNSS, GIS, Earth observation, which is the remote sensing, then that 3D scanning or the data sets. Technology which are now driving forces are there, the big data analytics, cloud computing, artificial intelligence, and many businesses processes are there, where that the environmental impact assessment, analytics, customer relationship, businesses. If you will see that if I am going to, if GNSS will stop right now, at least that 80% companies are going to be shut down. You can take a name that from Flipkart to Amazon to Google to say that Ola or Uber, all these companies are now applying on locational based data set. What are the impacts are there? If you look on that, the billions-dollar impact are over there, and that in the coming days that this impact is going to be grow. So the geospatial technology, if you'll see that growth is 2020, in fact, though, even that during that COVID period, it has achieved that 13.6% growth. That is very prominent growth, and it looked that in coming 2032, it would be going to be almost double what we have growth right now. So coming to that remote sensing, and that starting from that very basic, and I'm giving you that very prominent definition of remote sensing, which is written by Lillison and Kiefer, and it is that science and art. So the question comes, what is the science and what is the art? So talking about when art we are talking, it's basically acquiring information through their shapes, through their size, which we are more pertaining towards that art sides. And then science is over there, that the electromagnetic spectrum comes over there, surface reflectance come over there. So these things, when we are combining and to extract information of a certain object, then that we are calling it's a remote sensing. So it is going to be help you to understand the phenomena of a particular area. It is going to be understand of a particular object, what are the behavior of a particular object is over there. And on that basis that we are linking that one object to the other object, and through the modeling, we are able to find out something predictive. So the principle of remote sensing, if we'll see that the very basic, one is that reconnaissance from the distance, detection and the recording instrument, energy and that measured, and the two major components. If you'll see, so remote sensor, electromagnetic radiation, data collection and data analysis. So these are the things is required while we are going for the remote sensing. Remote sensing works on two ways. That the one is that which we are calling it passive remote sensing, which is basically that if we are using that some different source of energy, like sun is that another source of energy, which is going to be interact on surface and return back to the satellite. Then it is going to be download from that ground station, and finally it will be distributed to the users. So that is that one part of remote sensing. Then that another comes to that active remote sensing. So I'm very briefly telling you about this. So active remote sensing is that where that we are not utilizing other energy. We are utilizing that the own energy source, which is that like microwave or radar systems, which utilize their own energy, and it is going to be it is going to be reflect back to the sensor. And only the advantage of active is that no, it is all weather kind of a remote sensing. When that you have, if you have a cloud or if it is a cloud free, you are going to be get a data. However, that the passive remote sensing, that problem is the cloud is the one of the problem, or atmospheric pollution is that another problem to get that the proper information of the ground. What's the physics actually over here that if you'll see, generally we are utilizing that for optical remote sensing, we are utilizing that visible range and infrared range, which varies from that 0.8 to 0.4 to 0.8 micrometer. And then comes to infrared, which goes to 0.8 to 14 micrometer. Maximum those are working in the area of forestry, vegetations. They are using that infrared, near infrared, middle infrared, and that the far infrared. Near infrared is that more sensitive with the vegetation part. Middle infrared is more sensitive to the moisture, that water moisture, wherever that moisture would be there. So it is good to go for a study of soil moisture, then that you can utilize that middle infrared region. Then comes to the microwave, which I mentioned that it is that active remote sensing part, which range from that the 3 millimeter to the 30 centimeter, and it has the potential to penetrate from cloud. It has also potential to penetrate in a water at some length, and also have a potential to penetrate on that some length of soil also, but not much, but that at the sum of the bands they can penetrate up to that the certain centimeter inside a soil also. So that is the advantage of a microwave. We have maximum that the microwave people are utilizing it for that identification of a crop, generally during that the monsoon region, monsoon season. So yes, this I already spoken about that. So there that one important things which is that thermal infrared also come under that remote sensing. Maximum that which you are getting energy from a sun. We have some energy from that own sensor, and some energy comes from that earth surface. That energy is also we are extracting that information to identifying that what kind of objects it is, because during daytime it is going to be absorb energy, and at night time it will be release energy, and different object have a different behavior to release energy during the night time, and during that, and absorption during the daytime. On the basis of this, that we are able to segregate our different objects. So that's a active sensor which is working that the microwave remote sensing under this. Passive sensors are reflected radiation, visible, and the near infrared. Looking on that, we have over here that electromagnetic spectrum and spectrum bands, and both are not same thing. When I'm talking electromagnetic spectrum, it is that the continuous range. Continuous range started from that visible to that microwave. There are no gaps between this in this whole spectrum. However, when I'm talking about spectral bands, that spectral bands are discontinuous. They are designed according to that extraction of information in the different sensors. Like we have a blue band, green band, and a red band. So blue band, red band, and the green band, different sensor have a different range of blue, green, and red. It depends upon what kind of the object sensitivity is required a particular sensor. So some sensor have blue band start from 0.42 micrometer and end at that 0.48 micrometer. Some sensor designed start from 0.40 and end up to that the 0.50, and like this that the various bands are there, and that depend upon that the sensitivity of a sensor to particular objects. So this is that the basic physics which we are utilizing while we are going for to get that that information of objects. Now coming to how to achieve a sustainable goal. We know that the previous I have spoke about the technology. I have spoke about geospatial technology, where that remote sensing play a very important role, and the geographic information system play an important role. Now coming to this, that how we can achieve this. So coming one important aspect that the poverty, which is that the first our first goal is sustainable goal. Poverty is basically induced by a certain area due to that disaster. If the disaster is prevalent at a particular region, those area is going to be under poverty. So if I am going to be reduce my disaster or reduce the risk of disaster, and if I am going to be make that our community resilient to the particular disaster, then might be that I may be work to achieve my goal, that no poverty and the zero hunger. If you will look on that, so it is 7% the total economy loss which has been happened in the disaster that was happened by that the hydrometeorological based disaster. And that, where that if we'll say that a flood is over there, if we have a tsunami over there, we have a drought or we have a tropical cyclone. So total see that 87% economical loss, and in these the drought play a very important role. That in the total 60% loss was covered by only the drought. So you can see that the 675 billion loss has been done, and this is not my report, but it is that UN escape based UN escape report. So if we can save these much money, certainly that that we are going to be improve our society. Certainly we are going to be improve that our community, and that we can achieve that our no poverty and the zero hunger goal. So how technology work over here? So if you look on that, the drought actually, which basically if you see in the previous slide, so is 60% that economy loss is because of a drought. How we can work with that, the drought, how we can identify that the drought, their geospatial technology works are very if you'll see that the geospatial technology have given a very precise information for that. I'm talking about the very prominent area for that drought, reoccurring drought in the Marathwada region of Maharashtra, that is the central Maharashtra region. And this area gone to that the under the drought in 2003, 2007, 2010, 2012, and 2017. And it is the very intensified drought actually happening over there. And a lot of economical loss has occurred due to this drought or at this region. Not only that economical loss, human loss as well as the livestock loss is happening over there. And that's put this region towards that the poverty. You can find that Maharashtra is one of a very well developed state. But if you will see that the central Maharashtra region, where that